Okay, good morning. So, hopefully that you are doing great. So, let us start doing some examples. Last time I taught an important part of the lesson for you, but we didn't solve that many problems. So, let me just recall you. If you remember, we realized that two lines, L1 and L2, are parallel if if of course one of them is horizontal, the other one is vertical, or if both of them are inclined ones, then we compare the k values of these two lines. If they are equal, we see that they are parallel. If they are not, they are not. Okay? And then we also learned about what happens, how can I realize which lines so I made a mistake here. For parallel, either both of them should be horizontal or both of them should be vertical. In other scenarios, you can compare the k values. But for being perpendicular, uh, there are two possibilities. Either one of them is horizontal, the other one is vertical. We don't need to do anything. We just immediately realize if one line is horizontal, the other one is vertical, they are perpendicular. But if this is not this special case, how can I understand the situation? I just definitely, if you remember a theorem, we just calculate the k values. If I calculate the k value of the first one, if I calculate the k value of the second one, and if I multiply them, it turns out to be -1, then these two lines are perpendicular. Otherwise, they are not. And the reason that the multiplication should be -1, the product should be -1, I actually proved it for you last time, if you remember. Okay, now these are the problems that I have chosen to discuss today, and then there is one short lesson that I want to teach you, and most of it, mostly it is actually GeoGebra work. You want to solve a system of equations using graphical tools. I will come back to it later, but let us solve these problems together. The first problem, show that the lines this one and that one are parallel. Okay, so this line is neither horizontal nor vertical. Why? Because for vertical lines I only need to have x in my equation, and for horizontal lines I need to have only y in my equations, but here I have both of them. So this is neither a vertical line nor a horizontal line. The same is true for this one. So if I want to see if they are parallel or not, I need to calculate the slope of this one and the slope of that one. If they are equal, they are parallel. If not, they are not. But this problem is claiming they are parallel, so hopefully if we do the calculation, we see that the slopes are the same. But this is the general form of an equation for the line. So I need to write it in the k form so that I can immediately realize what is the slope. So the first thing that I do, I want to read the k value, so I need to write it in the k form. So what does it mean? It means that y should be alone on the left hand side. So I will keep 2y here. I move 3x to the left, to the right, it becomes negative 3x. And I move 1 to the right, it becomes negative 1. But because I want to make y alone, so I divide everything by 2, the left hand side just simply becomes y. The right hand side, there are two terms to be divided. If I divide the first term, it becomes this. If I divide the second term, it becomes this. But now it is easy to read the k value. So the k value of this line, let me call it k1, this is minus 3 over 2. Yes? So I will do the same thing for the second line. So 6x plus 4y plus 3 equals to 0. Then what I do, I keep 4y on the left and I move these two on to the right. And then I divide by 4 to make y alone. It becomes minus 6 over 4x minus 3 over 4. But minus 6 over 4 can be simplified a bit more, so it becomes minus 3 over 2x minus 3 over 4. And if I now ask you what is the k value, so you realize that the k value, let us call it k sub 2, it is in the second line, it is minus 3 over 2 again, yes? And then you would say that therefore k1 is equal to k2 and the lines are parallel. Okay, very simple. Please interrupt me if you don't understand something. Okay, so this problem is also important to know. So this is a standard problem. Determine an equation for the line that passes through this point and is parallel to this line. Okay, so here, if I want to sketch something for myself, you don't need to be precise. Just I want you to understand the geometry. You have a line. The equation is given, but this represents a line. So let me just draw a line. I'm not saying that this is the real graph for this particular line. I'm just understanding the problem by doing some sketch. So, and then I have a point, and then do you think that this point lies on this line? Because these are important things. How can I do? I replace x with minus 3. I replace 2 with y. So y with 2, sorry. Then it becomes minus 9 minus 4 plus 1 is equal to 0 or not. But this is wrong. It means that this point, the coordinates of the point does not satisfy the equation of the line. So it means that this point is not on the line. So let me assume that just this is my point A. So what is my goal? My goal is to find an equation for the line that passes through this point. Of course, there are infinitely many lines that pass through this point, but I want to find the one which not only passes through this point, but is also parallel to this green line. So for example, this would be a good representative of that line, for example. Yes. So here I want to have that line. This is my question mark. Okay, and then do you remember for writing an equation? So this is the line that is missing. I want to find its equation. But you need to remember there is one standard way of finding an equation for the line. Yes? And that is having one point of it. I don't have any problem here because by understanding the problem I realize the point A lies on the line. So that's good. But what is missing is the slope. I need to find the slope of this question mark. Okay, but the slope is also clear, yes, because I can find the slope of this green line because the equation of that green line is given. And now I want to have this blue line to be parallel to the green line. So whatever I read for the k value of the green line will actually serve as the k value of this blue line. And then I am done because I have the k value and I have a point here. You can use the 1-point formula to write the equation for this blue line. Okay, so that's the idea. So I would say that let me call this line L. Okay, and let us see how this will go. I would say that if I will do the same problem as the previous one to find its k value. How should I do that? I will keep minus 2y here. I move 3x to the right, 1 to the right, divide by minus 2. So it becomes 3 over 2 plus 1 over 2. And then I realize that the k value is equal to 3 over 2. But this is the k value, for example, for this green line. Imagine that, and then it implies that the k line, the k value for the L line is also the same, since the line is supposed to be parallel to this line. The k value, its k value will be the same. Okay, so then I have the k value, I have 1 point. So this is the formula, 1 point formula, yes? So I want you to understand why I am taking the slope of the green line and use it to write my equation, because they are supposed to be parallel, so the k values have to be the same. So y minus y node is the y coordinate of my point. K value is 3 over 2, and then I have x minus 3. X node is the x coordinate of one of the points that I know. I know about it. Okay, and then what should I do? I can write my y minus 2. I multiply 3 over 2 inside, so it becomes 3 over 2x. This one minus becomes positive, and when I multiply 3 here, it becomes 9 over 2. And then to simplify that, I move 2 to the other side. It makes it positive. And then it's better to take the common denominator. So the final answer that we are looking for is y equals to 3 over 2x plus, instead of 2, I can write 4 over 2, and then the denominators are the same, so it becomes a 13 over 2. So that is the answer to this problem. Okay, any questions? So this problem is an important one. So remember the ideas, how we argued about the k values and things like that. Okay, there is also another type of problems you might face. The lines, this one and this one, are parallel. Determine the value of a. So you see, in one of the equations I do not have any undetermined coefficient. The coefficients are 4, minus 1, and 1. But here I have two problems. First of all, x appears in two places. You know that in the equation, the standard equation for a line, either it is 1.4 or the k form, x appears in only one place. This is one problem. The other problem is that the coefficient of x is an unknown number minus a here, and the point of this question is to determine that value so that the lines representing these two are actually parallel. Okay, so when you see that the question talks about two lines being parallel, the first thing comes to mind is to calculate the k values and equate them. Finding the k value of this one is actually a standard one, so let us do it quickly. I move 4x and 1 to the right, and then I divide. I want to make y alone, so I multiply by a minus sign to get rid of minus y and make it y. On the right hand side it becomes 4x plus 1. So the k1 value, the k value for the first line is 4. Okay, but now for the second one, I have 3y minus ax is equal to x plus 2. So what I have to do, I want to make y alone. Okay, so I will do the same thing again. I move ax to the right, minus ax to the right, it becomes positive ax. There is an x there, and of course a 2. But you see that x is appearing in two places. Okay, if you just say that a is, if I divide by 3 and make it this divided by 3, this divided by 3, this divided by 3, that's okay. But if you say this is the k value, that is wrong, because it is the k value if x appears in one place and the coefficient of that x in total is the k value. So before doing that, it means that this motivates me to write x in one place. So this motivates me to factor an x out. Then a is left from the first one and positive 1 is left from the second one. Now what appears, you see that there are no two x's. Here I have one single x. So this is the correct way of doing it. So I will write it as 3y equals to a plus 1 x and then plus 2, but still y is not alone, so I divide everything by 3. The right hand side becomes a plus 1 divided by 3x, and the other one is 2 divided by 3. Now everything is ready. If I ask you what is the k value, let us call it k sub 2, means the second line, for example. If I ask you what is the k value, what's the answer?
4.
Pardon?
A plus 1 over 3
yes.
equals to 4.
Plus?
Sorry, what?
Okay, a plus 1 over 3, yes. So this is the k value. But now you want to have these two lines parallel, yes? As you said, we want to have line L1 to be parallel to line L2. So this implies that the k value 1 should be equal to k value 2. So this means that 4 should be equal to a plus 1 over 3. But then you know what to do. You multiply everything by 3 to get rid of the fraction. It becomes a plus 1. Then hopefully everything is clear. A is 11. And that is exactly what you need to write as the answer, because the question asks you about the value of a. So the answer to this problem is exactly what you have got here. Okay, so that's also one type of questions that you might face. If there is something you don't understand, please ask questions. Okay, let us go to the next page. This time I want to talk about perpendicularity, yes? Again, show that these two lines are perpendicular. Hopefully you know what to do, yes? What we are supposed to do, we actually find the k values, but this time I need to multiply them. If the product is -1, then they are perpendicular. If it is not, they are not. And of course, before doing that, you need to be considered this special case, horizontal and vertical. But none of these lines is a horizontal or vertical line because they have both x and y present in their equations, yes? So again, let us just do it fast because this is exactly the same story up to finding the k values, and I think every one of you knows how to do that. So 3y is equal to minus 2x plus 1. I divide everything by 3, so it becomes minus 2/3 x plus 1 over 3. So the k value number 1 for the first line, for example, is minus 2/3. And then I will go to the other one, 3x minus 2y plus 5 is equal to 0. Then minus 2y is equal to minus 3x. Minus 5 divides by minus 2. This becomes 3 over 2x. 3 over 2x plus 5 over 2. Now if I ask you what is the k value, you say that this is 3 over 2. And now I multiply k1 by k2 to see what the number is. The first number is minus 2/3 and the second number is 3 over 2. And I hope that you immediately see that this 3 and that 3 are cancelled, this 2 and that 2 are cancelled. Because of that negative sign, I get minus 1. So therefore, the lines are perpendicular. Okay, so that was also very simple. Again, a standard problem we have here. I can compare this example number 5. Determine an equation for the line that passes through the point this and is perpendicular to this line. Do you remember the structure of the sentence is the same? In the previous problem, determine an equation for the line that passes through the point and is parallel. We learned how to solve this. I emphasize on this problem. Make sure that you understand this. And then another similar problem for the perpendicular case is the same problem here. So let me sketch a little bit small figure for myself to understand the problem. So here I have a line. Its equation is given. So let me draw a green line. It's just a sketch. I don't want to be precise, so I don't know even if this is the correct way of drawing this line. But anyway, so that's a line, and this is a point. You can check its coordinates here. You see that it doesn't lie on the line, so A is somewhere, for example, here. Now you are interested in this blue line that I am going to draw, the line that passes through this point and is simultaneously perpendicular to this green line. Yes, so what I do, I just draw it. This is not a good way, so let me try to make it a little bit better. Okay, yeah, hopefully this is good. Yeah, so this is perpendicular. So the question is about this blue, an equation for this blue line. Okay, again, you shouldn't get confused by the geometry. If you want to write an equation for an unknown line, an equation for a line, you need to have two pieces of information. You need to have one point on the line whose coordinates are known to you. Okay, so that is clearly this point. Why? This is given directly in the problem. The second thing that you need to know is the k value of your line. Of course, the k value is not given to you directly in the problem, but this equation of this green line is given, and you already learned how to extract the information regarding the k value from its equation. So it means that if I ask you, is the k value of the green line known to you, you would say, yes, I know how to find it. And then I can ask you, is the k value of the question mark is now clear to you? You would say yes, because this line is supposed to be perpendicular to this line. Whatever I get here, I reciprocal it. I find the reciprocal and minus is multiplied by minus sign. So you see these two lines were perpendicular. What's happening? The numerator and the denominator are swapped, and then I have also an extra negative sign. So that's the story. Hopefully everything is now clear, and then you can use the 1-point formula, for example, to determine an equation for this blue line. So let us just do it. So 2x minus 3y minus 1 is equal to 0. So I will keep this one, move the other ones to the right, and then divide by minus 3. So it becomes 2/3 x minus 1 over 3. So the k value of the green line, for example, let me write g green or whatever, is equal to minus 1/3. Yes? And if I ask you what is the k value of the blue line, what is your answer? You need to interchange these
It should be
two.
the same.
Pardon?
No, sorry, it should be the reciprocal of the green.
Reciprocal and multiplied by a negative sign. So if I reciprocal it, it becomes 3 over 1 negative. But I am also allowed to, I have to multiply by a negative sign, so it becomes this number. A number that when multiplied by minus 1/3 gives you minus 1. So what is that one? It's very clear. So it's 3, yes? Why is that? Because I see immediately when I multiply this number by this number, it becomes negative 1. So if the k value of one of them is minus 1/3, the k value of the other one in the pair becomes 3. Okay? Now I have the k value. I also have a point, so I can write this formula. Y minus y node is equal to k x minus x node, and just replace what I have now. Instead of y node, I put minus 1, the y coordinates of this point, and instead of k, I just write 3 and x minus x node, which is 2, and then simplify that. So it becomes x plus 1. Y plus 1 is 3x minus 6, and I move y to the right, 1 to the right. It becomes negative 1, so it becomes negative 7. So the answer that you are looking for is this equation. So these two problems are very simple, but definitely you will have questions like this in the exam. Okay, but I want you to understand the geometry. Is that clear for everyone?
Yeah.
Yes.
Good, thank you. Now, another type of problem, the same story, but here. So if you don't mind, let me pause the video a little bit so that you can solve this problem. It's not exactly the previous problem, but the ideas are more or less the same. So I'm sure that you can solve this problem yourself. So let me give you 5 minutes. I will pause the video now.
I got A is equal to positive 4, but I don't know if it's
Positive
correct.
4, okay.
I
think
got A is equal to 2, but I don't know either.
2 is
I have
correct.
the same answer as well.
2 is correct.
2 is
Okay.
correct, and I think you did a small mistake because of negative sign. This is why if you make a negative sign mistake, you get A equals to 4. But let me see.
Yeah, then A, the other one would be equal to 1, not negative 1.
Yeah,
That's right.
yeah. So A should be 2, yes. Okay, so good. Let us check what is the answer. So the first one is simple because this is just a very standard one. I want to find the K value. So Y is equal to, I keep minus Y on the left, I move 2x to the right, it becomes minus 2x plus 7, then I multiply by minus 1, Y becomes 2x minus 7. The reason that I am doing it because I'm interested in finding the K value. So let me call it K number 1, it's 2, yes? And now I want to do the same thing for the second line, but now you have enough experience. First of all, this is not a standard at all because again you see x 2 places. In this problem you can also see y in 2 places, but you understand what's going on. So I need to move y's to the left because I want to make y alone on the left, and then I move x's to the right. So let us see how it goes. So here I have a minus 2y on the left from the beginning. I move minus 4y to the left as well. It becomes positive y. On the right hand side I have a times x, and this 3x I also move it to the right hand side. It becomes negative 3x, and then I have also a 5 on that side. But the left hand side is just simply 2y's, and the right hand side I can just factor x out for the same reason because I want to have x in exactly one position. So this becomes a minus 3 times x plus 5. And then to make y alone, I have to divide by 2, so y becomes a minus 3 divided by 2, x plus 5 over 2. Yes? And now if I ask you what is the k value of this second line, so let me call it k number 2, this is hopefully understandable for everyone. This is the coefficient of x. Yes? And now line 1 is supposed to be perpendicular to line L2. So what does it mean? It means that K1 multiplied by K2 should be equal to negative 1. Okay, so K1 is 2 multiplied by K2, which is this number. It should be equal to minus 1. But here I can simplify this 2 with that 2, so a minus 3 is left. So this means that a minus 3 is equal to minus 1. Then I move 3 to the right, it becomes positive 3 minus 1. So as Rocco said exactly, and Kajal also, I think you made a mistake for this last minus sign, yes?
Yeah, I said
Yeah.
minus 3, and that would be equal to 1.
Yeah. So this is the answer. So you see, the problem is simple. Here, A is determined if you are supposed to determine A, so actually this is your answer that you have to provide. Let us check this with GeoGebra to see if GeoGebra is also capable of understanding this. So the first line that here I have is 2x minus y. I remember that GeoGebra was able to draw this equals to 7. Yes, so this is the graph of this one. But of course the graph of the second one, we shouldn't expect GeoGebra be able to give me a definite line because A is missing there. So this, let me just type the equation to see what happens. So ax minus 4y plus 5. What I expect is to create a slider, and that's correct. So you see that I have different lines when I start moving this around, yes? But if we are right, if I go back here, we realize that this, when a becomes 2, then this line becomes perpendicular to my line, yes? Let us check that. Let us increase this so that this value of a, now the value of a you see is minus 2.4 here, and then of course even by your eyes you can see that they are not perpendicular. But let me increase it to positive 2. If our prediction is correct, when a becomes exactly 2, they are perpendicular. And then let us see what happens. So this is exactly when a equals to 2. Of course, according to what we see, it's reasonable. If you want to choose to use the tools in GeoGebra to understand that, what I will do, I will go here, choose the intersection point, because I need some points. So this will give me this intersection point. The intersection point is this number here. And now I choose 2 random points because let me just choose a random point here and a random point here because I want to use this measuring tool, angle measuring tool, and for that you see that I need 3 dots, and then you need to do it. The middle one should be traced in the middle. So for example, I start from here and then go here and then go here. So you see, at least if we can trust GeoGebra, its calculations, you see that this angle is 90 degrees. So it is actually confirmed that among all infinitely many possibilities for this line, when a takes on exactly 2, you see, and we also confirm by this tool, then that line becomes perpendicular to this line. This is what is going. What is the meaning of this calculation. Okay, so now let us see what we can do next. So this is also something I want you to think a little bit, and then I will come to you, okay? So let me just read the problem for you. The points A with these coordinates B and C are the vertices of a triangle ABC, for example. Determine an equation for the line. This is not one, this is on which. So let me just, on which the altitude corresponding to vertex A lies. So what does it mean? So you know that I draw and clean it. If you have any triangle, this triangle, for example, say ABC, there are 3 altitudes. Altitude is a line segment that you start drawing from one vertex and draw a perpendicular line to the opposite side. This is one of the altitudes corresponding to vertex A. You can have an altitude corresponding to vertex C, for example. You have to draw a line from C to its opposite side and perpendicular to this. This is also an altitude of the triangle, but that's an altitude corresponding C. You can also have an altitude corresponding B. So there are 3 altitudes. Here, in this problem, I am asking you, determine an equation for the line on which the altitude corresponding to vertex A lies. So this is the altitude of vertex A. And then this line segment lies on this line, of course. And then I am asking you find an equation for this line. I want you to do that, okay? I give you a little bit of time. Okay, so the first thing here, I don't know why this might be a little bit hard for you. That is more or less the same thing, yes? So let us analyze the problem. In these kinds of things, you need to analyze the geometry first. So what I do, I just sketch a graph for myself. Okay, so for example, this is my triangle. I'm not saying that this is the triangle represented in the problem. I just drawing a picture for myself to understand the problem. So this is my triangle. And then what I want to do, I want to find an equation of the line on which this altitude or height is actually lying, yes? So let me call it AH. And then what I want to understand is what is the equation of this line here, for example, if I can draw it. This line. This is the equation of the line that I want to find, yes? But again, don't get confused by geometry. Your goal is to find an equation for a line. So you need to look for two pieces of information. If they are given directly, these are the simplest possible problems. If not, you need to look more closely to be able to extract the missing pieces of information from the problem. So what I need a point and I need this slope. A point, I don't have any problem because this is supposed to contain the altitude. So it means that one point which is given in the problem and I know lies on my line, that's enough. The problem is the k value. What is the k value? The k value for this, how should I find the k value? I know the height is perpendicular to BC. And this is good because I have information regarding B and C. I have 2 points of this line. Okay? So using 2 points of the line, you can immediately use delta y over delta x to find the k value of BC. And then the problem is simple, isn't it? When you find the k value of BC, the k value of the question mark is the negative of the reciprocal of the k value of BC. And I am done. So I don't know why you were confused. You shouldn't let the geometry actually disturb you, okay? So you need to understand what's going on. So if I want to follow the steps, the first thing that I will do, I will say that, okay, I want to find the k value of line segment BC. So let us put these subscripts that you understand what I mean. This is the k value of the line segment BC. Okay, so how can I write that? I can write the difference of the y values. So for example, y of point B minus y of point C divided, I have to keep the same order. If I have chosen to bring B first, here I also have to bring B first. So this is the same famous formula, delta y delta x, yes? Okay, now you can read the information in the problem. What is y of B? You see it is 3. What is y of C? You see it is minus 3. So it becomes 3 minus minus 3. And then what is the denominator? xb, you see x of b. The x coordinate of b is minus 1. The x coordinate of c is 2. So it's minus 1 minus 2. The numerator you will have 3 plus 3. In the denominator you will have minus 3. So it becomes 6 divided by minus 3. It becomes negative 2. So the k value of BC is equal to negative 2. But why this is helpful? Because if I ask you now what is the k value, so here I can write it immediately. So what is the k value of my missing line? I am not interested in BC. I am using BC to solve my problem. When I know that k of BC is equal to this, so let me write it more carefully. So because I know that these two lines are perpendicular, so I know that AH is perpendicular to BC. If I ask you what is the k value of AH, so what is the answer? If you want to do it in your head, the reciprocal multiplied by a negative sign.
1/2 negative. Negative 1/2.
No, positive 1/2. So don't get confused. You need to do reciprocal and multiply it by a negative sign. Always. Reciprocal, negative. Negative of the reciprocal. If I ask you what is the reciprocal, you would say the denominator is 1. So the reciprocal becomes this. And now you have to multiply it by a negative sign. Always. Negative of the reciprocal. So it becomes positive 1/2. So this becomes positive 1/2. Now I have the k value exactly of the line missing, demanded in the problem. Do I know a point of that line? Yes, it is clear from geometry that that point can be A, and that's enough. So I would write y minus y node is equal to k of AH. So it just let me write k of, and then multiplied by x minus x node. So this becomes y minus y node. But what is y node here is the y coordinate of the point that I'm sure lies on my line. So it becomes y minus 2 is equal to k value is 1 over 2. X minus x node is 1. So then I have to simplify this. So I multiply this by 1/2. Here you see this happens, and usually I move the minus 2 to the right. And then 2 minus 1/2 can be simplified a little bit more. So this becomes 1 over 2x plus 3 over 2. So the answer that you have to provide for this problem is y is equal to 1 over 2x plus 3 over 2. Let us demonstrate this using GeoGebra again, but I have these points in front of me. I will just highlight these points on GeoGebra and make the triangle to see what is going on. Okay, and then I will type this to see if this is true or not. Okay, so let us get rid of all these equations. We don't need them. Okay, the other one is this one. Okay, now what I want to do, I want to, by the way, it's better to delete these points because I want to use the same names here. So let us just get rid of everything. Okay, so the first point is A with coordinates 1 and 2. So this is one point, you see. The other point is B, minus 1 and 3. Yes, minus 1 and 3. Why I don't see it? Okay, I have to put equality. I'm not following the syntax. Okay, so this is that one, and then the other one is 2 and minus 3. Okay, so C is equal to 2 and minus 3 minus 3. Yes, this is this, and I use this to make my triangle. So I will this point and that point and that point, and then come back again. So that's my triangle, and I would recommend here it's better to show the label. So this is point A, not to get confused, and this is this one. Yes, so this is my triangle that I had in in the problem. And now if you go back here, what I want to do, I want to type this equation as the answer, and then if everything is right, this equation should be along the perpendicular line. By the way, GeoGebra is also capable of doing that for you, but let us just do it later. By the way, let us check that. So here, if you choose this tool, this is a point and a line. So I just choose this. You see it's perpendicular line, so you need to highlight a point. So this probably solve my problem. So I choose this point and I choose this line, and then GeoGebra immediately draws this line. Okay, and then here you see also GeoGebra gave me the answer. It's minus x plus 2y equals to 3. So that is exactly the line that I was looking for. Yes, because now if I find the intersection point between this one and this line, I get this, and now I can make the angle to see that this angle is 90. Of course it is. So I have to go the other way around because it's just drawing clockwise. So I go from here to here and there. So this angle is 90 degrees as we expected. I don't know what happened. Suddenly gave all the angles. Okay, so let me just show it in a better place here. So that's one way, and then let us see. You see, GeoGebra gave me the answer actually. Just solve the problem. Minus x plus 2y equals to 3. Is this the line that I got? So let me just remember this in your head. Minus x plus 2y equals to 3, and let us go back to iPad to see that's the same line. If I want to make it exactly the way that GeoGebra did, so let me change my color. I multiply everything here by 2 to get rid of those denominators. So it becomes 2y is equal to x plus 3. And then I move x to the left. It becomes minus x plus 2y equals to 3. And that is exactly the answer GeoGebra actually provided for us, yes? Yes, minus x plus 2y equals to 3. So that's one way of understanding this. So it was very nice that we were able to solve it completely using GeoGebra. So you need to use these tools in GeoGebra effectively. Now, so everything is clear. Hopefully you understand what it means. Yes? Any questions?
No.
Okay. So at least you understand when you calculate something, what is the meaning of your calculations. Okay. Okay. Now let us do the new lesson. Of course, the new lesson is very simple. So the problem is that what are the relative positions of two lines actually in plane? So what do I mean by that? So let me go to the new page. So for example, if I have a coordinate system, if I ask you, I give you two lines, what are the relative situations of these two lines with respect to each other? Of course, there are three possibilities. Okay? Either the lines are parallel, or the lines are intersecting, or the lines are lying on top of each other. Actually, they are the same lines, yes? So, for the case of being parallel, I can have, for example, this line and that line approximately by hand, yes? So these are a pair of parallel lines. I might have a pair of intersecting lines, yes? Of course, they might intersect at a smaller angle than 90, or they might intersect exactly at 90. By the way, if someone asks you what is the angle between these two lines, this is convention. By convention, you calculate the smaller angle. This is to remember. If someone asks you what is the angle between these two lines, of course there are 4 angles. 2 by 2, they are the same. One of them is the acute angle, the other one is an obtuse angle. By convention, they ask you what they mean the acute angle. Unless they are perpendicular, in that case, all 4 angles are 90, and of course the angle between the lines is 90. But there is also another scenario might be going on, and this is of course a little bit strange why we are considering this case, because sometimes two different equations represent the same line. This is why we don't say the equation of a line, we say an equation for the line. So this, I will talk about this also here. So for example, what might happen? It might happen that I have a line here. Okay, I don't know how to draw it, but so the other one is exactly on top of this. Yes, so yeah, let me make the other one with a black color, so it is, and let me make it a little bit thicker so that you, of course it doesn't matter if I will stay, it makes it the same. Okay, and then the other one, let me just draw it a little bit on top of that. So these are the relative positions of two lines. Either they are parallel, or they are intersecting, or they are the same. For this one, let me also demonstrate it using GeoGebra. So for example, if I just draw let me just draw two equations for you. So if I draw this equation, so let us say for example x plus 2y is equal to 5. This would be this equation. Okay, and let me change the color here. For example, let me make it red. So this is one equation. And now I want to draw another equation, but this would be 2x plus 4y equals to 10. from algebraic point of view, these are not identical equations, they are equivalent equations, but you see that both of them are lying on top of each other. So if I make, I don't know, yeah, you see that if I just get rid of one of them, immediately the other one appears. So these are on top of each other actually. So you see this equation is not identical to this equation. I mean, everyone can see the differences. The coefficients are different. But these two equations from algebraic points of view are equivalent. So this gives rise to the same lines geometrically. And why they are equivalent? Because if I multiply the first one by 2, I will get the second one. And if I divide the second one by 2, I will get the first one. So whenever the first one is true, the second one is also true, and the other way around. So from mathematical point of view, these two statements are completely equivalent. And this is not surprising. Yes?
I have a question.
Yes?
Are those lines parallel?
In principle, some books, this is, I don't know, it depends to the conventions. Yes, they consider these parallel because the slopes are exactly the same. Actually, everything is identical. This is a little bit strange because in our definitions, usually we say that two lines are parallel if they do not have any intersection points. But here they have infinitely many intersection points. Might be this violate the definition. But on the other hand, they have the same slope. So that's not very far from understanding to say that they are parallel. It depends to the convention, but I will distinguish between these situations. So when I say parallel, from now on I will consider not intersecting. And intersecting means there is exactly one intersection point, and I would say that they lie on top of each other or something around these, then this means that I am facing this situation. But the important thing is not this terminology. The important thing is that I can have two different algebraic equations, but they still represent the same line geometrically. This is the important thing that you need to appreciate. So it means that whenever I have two equivalent equations, you shouldn't expect that you get two different answers. So anyway, if I ask you how many points of intersections are there for this line and that line, then you would say all of them. So there are infinitely many intersection points for these two lines. So if I put these equations in one system of equation and ask you how many solutions are there, so let me just go back to iPad. For example, if I give you line L1 with some equation, so for example ax plus by plus c equals to 0, and this one, let me write a1, b1, c1 for L1, and L2 is a2x plus b2y plus c2 equals to 0. If I put this in a system of equations, you see, this is a system of equations. This is a algebraic problem. So for example, I ask you to solve this equation. So the same equations, I would say 2x plus 2y equals to 5, and I would write 2x plus 4y equals to 2. If I ask you to solve this equation, this is a system. Do you remember? You have a little bit of familiarity with this. So in principle, you should be able to solve this equation algebraically without referring to the geometry at all. But this is the lesson today. If I want to solve this problem, finding those values of x and y which satisfy simultaneously the first and the second equations, this is an algebraic problem. There is no geometry involved whatsoever here, yes? But a nice way to understand this problem is from geometrical point of view. Because if I ask you what is the geometric representation of this equation, by your knowledge so far you will tell me this is a line. and this is also a line. So when you are looking at a system of equations, it means that you are looking for those numbers x and y so that those numbers satisfy this equation and that equation simultaneously. If an x and y satisfies this equation, it means that the point corresponding to this lies on this line. And if x and y is supposed to satisfy this equation, it means that the corresponding point lies on this line as well. So it means that if I draw the graph of this and draw the graph of this, then I find the intersection point, if any. The coordinates of that intersection point is the solution for this algebraic equation that might rise from completely different context, not geometry. But this is a very nice interconnection between geometry and algebra. So today's lesson is telling you this. If I give you a system of equations containing two equations with two unknowns, in tomorrow's lesson and after that, we will learn how to solve this by algebra without referring to the graph, which is of course the important part. That is the precise way of doing that. But I want you in this lesson you learn what is the connection between solving this system and drawing the graphs of these equations. You draw the graph of these equations, which are lines. There are three possibilities going on. Okay, so this is very easy, by the way. Let me just tell you, this is not easy from algebraic point of view. Could you say this to me before this point of view? If I give you this system and I ask you what are the possibilities for this system, you couldn't answer this question directly using algebra. It might be a little bit complicated, actually more than a little bit complicated. But by this geometric picture, you immediately tell me there are three situations that can occur. If this is going to be the case, there are no solutions for this system because there is no intersection point at all. If this happens, it means that I have one unique intersection point. So it means that I have one unique solution for this. And when this happens, how many intersection points you have? You have infinitely many intersection points. So then I will have infinitely many solutions to my system. You might say that, okay, why this is surprising? Because how should you know that there is no possibility for having two solutions? How do you know that there is no possibility to having three solutions? From algebraic point of view, understanding these things are hard. But from geometrical point of view, it is very clear. If you have a system of two equations, there are only three possible scenarios going on. Either your system has one unique solution, or it doesn't have any solutions at all, or it has infinitely many solutions. You cannot write a system of equations that will have two solutions. The number of solutions 0, the number of solutions 1, suddenly the number of solutions become infinity. There is nothing in between. You cannot write a system of equations in two unknowns so that that system has exactly two solutions. It's not possible. It's very, very trivial by seeing this picture. It would be much harder to convince yourself about this fact by manipulating this system algebraically. So this is the benefit of knowing geometry and algebra. Sometimes answering one question in geometric picture is easier, we go there. Sometimes it's algebraically easier, we go to algebra. So if you know the nice ideas, the connection between geometry and algebra, you can conclude a lot of things. So now immediately you realize, for a system of two equations in two unknowns, there are only three possibilities. Either my system doesn't have any solution at all, or it has exactly one solution, or if it doesn't happen, suddenly it has infinitely many solutions. nothing in between. 0, 1, infinity. So is that understandable what's going on?
Yes.
Okay.
Yeah.
So for example, how should I understand this algebraically? There is no solution for this. If you want, you can go and draw the graph of these two. So let us go and confirm this using GeoGebra. X plus 2y is equal to 5, 2x plus 4y is equal to 2. So let me just draw them. Let me get rid of these. And let me type. The first one was, I have it in front of my eyes. You might have forgotten, but trust me on that. So this is one equation, and then let me write 2x plus 4y equals to 2. And this is another equation. Okay? So you see these two lines are parallel. So is there any intersection point here? Yeah, we can actually zoom out to see if there is something we don't see. Apparently not. That's, of course, there is no guarantee that there is no solutions. Again, hopefully you remember, might be. This is why algebraic methods are superior here, because might be these two lines have very, very close slopes that your eyes cannot differentiate between the slopes, and you might think that they are parallel, but if you continue, I don't know, for a very negative values or very positive values, for example, after 1 million, after 1 billion, immediately you will see that there is an intersection point. Of course, forget about those things, but I want you to understand algebraic method is actually superior here. So geometric picture is good to understand the problem. So for example, definitely this is true by geometric picture, that the system of two equations in two unknowns has either no solutions, one solution, or infinitely many solutions. This is definitely true by geometric picture, and it doesn't matter if our eyes cannot detect the differences. That is not related to this. Okay, but at least you see that there shouldn't be, if everything seems right, there shouldn't be any solution. So let me go back, for example, here. Assume that you didn't know about this and you just wanted to solve this equation. What will happen? You see that strange things will happen. I don't know how much you know, but you will be able to understand that. So for example, I will write x equals to 5 minus 2y. And I will teach about these methods later extensively. There are two methods, method of addition and methods of elimination. So that's elimination method or substitution method. I find one variable from one equation and replace it to the other one. So then it becomes 2, 5 minus 2y plus 4y equals to 2. And then you see why strange things happen. So this becomes 10 minus 4y plus 4y is equal to 2. Then unfortunately this y that you are looking for is cancelled, and you get a nonsense statement that 10 is equal to 2, which is definitely false. What does it mean? It means that if you insist that I can find an answer for this, you have to admit that 10 is equal to 2, which is not possible. So it means that assumption that there is an answer for this doesn't make sense. It means that there is no answer for this solution. So you see, in algebraic way, this is also possible, but this becomes harder because in engineering or I don't know science, you are facing millions of equations with millions of unknowns simultaneously. This way of geometric way of thinking, connection between geometry and algebra, give rise to some algorithms that you can immediately implement those algorithms in a computer, and that computer will take it. But in principle, I say that this is not a very hard problem. But if the number of unknowns and the number of equations become very big, then solving this systematically becomes harder and harder. So what I'm saying is that you see that from algebra point of view, you can also understand there are no solutions for this. From geometric picture of point of view, you can also see that there is no solution for this if you can rely on your, if you can trust your eyes here actually. Is there any problems here? Is everything clear?
Yes, everything's clear.
Yeah. So this is very important to realize that systems of two equations in two unknowns have three possibilities, even from algebraic point of view. Understanding this from a geometric point of view is very simple, but if you want to convince yourself of the validity of this argument algebraically, I'm not saying that this is impossible. It's possible, but much harder. Okay, so now if I give you a system of equations and I ask you to solve it graphically, what you do, what are the steps? You go to your graphic tool and then draw the graph of one of them. You go to the graphing tool, draw the graph of the second one in the same coordinate system, and then see what happens. Yes? If this happens, there are no solutions. If this happens, there are infinitely many solutions. Every point you see is a solution. Okay? But if this happens, you have exactly one solution, and the x coordinate of this point is the value that you have to choose for x, and the y value for this point is the value that you have to choose for y to make these equations simultaneously true. Okay? So for example, let me ask you to solve this, for example, using GeoGebra graphical tool. Today's lesson is only graphical tool. So for example, I have x minus 2y plus 5, and then 3x plus 2y is 10. We want to solve this equation graphically. This system of equations. This is not one equation. This is called a system of two equations in two unknowns. My goal is to find all possible values of x and y so that when I feed them in this two equations, these equalities are simultaneously true. Okay, so let us go to GeoGebra. You don't need to memorize it, just trust me. I will type these two in GeoGebra. Let me just delete this one and delete this one. So let me make the coordinate system available. I don't know. Okay, so it's far away. So let me bring it somewhere more reasonable here. And then let me just type those equations here. So this is x. This is x minus 2y equals to 5. Yes, and then we go 3x plus 2y is equal to 10. This is another one. So then what you need to do, there is also, if you read the book, the book is giving you the instructions how to use similar ideas on a calculator. Yes, but here I use GeoGebra. This is the intersection point, so I click on it if this is not highlighted already. And then I will click on one of them and the other one. It gives me this point, and then the x coordinate is the x value and the y coordinate is the y value. But of course, when you do it graphically, these numbers might be not the exact values. These might be approximate values. Of course, you can change these to more higher precisions, but anyway, algebraically, the point is, this is the power of algebra. You can find the exact values, but using this graphical tool, if we are lucky that this point lies exactly on one of these grids, we can read it by our eyes, or if the point, I don't know if this is the exact value, I have to calculate it myself to see that if these are exact values. Let us, by the way, check them, okay? But this is today's lesson. You want to solve this system of equations graphically. You draw the graph of these things by your graphical tool. Is it a calculator, is it GeoGebra, or whatever? And then you need to find a command in that program that you're using, or your calculator, to be able to give you the exact position, exact in quotation mark, exact position of the intersection point, and read the coordinates. So here I would say that x is equal to 3.75 and y is equal to this one. Might be these are exact values. We can check. Let us go back to algebra So if I want to solve this problem algebraically, which is of course not the lesson today, I will teach about this systematically tomorrow. From here I will get x, so from here I will get x is equal to 5 plus 2y. I am moving 2y to the right and then plug it here. So this becomes 3 times 5 plus 2y plus another 2y is equal to 10. So this becomes 15 plus 6y plus another 2y is equal to 10. So this becomes 8y is equal to 10 minus 15, which is minus 5. And then y becomes minus 5 divided by 8. I think this is the exact value. Minus 5 divided by 8. So let us go to algebra. So y is equal to minus 5 over 8. So minus 5 over 8. Yes. So this was actually coincidence. This number is the exact value for this. Okay. And then definitely this one is also exact, I think. Yes. So how should I solve that, by the way? This is, of course, I am looking ahead of me. We will talk about this systematically later. Don't worry about if you don't understand the algebraic one. And then if this is done, I will take it and put it back here to find my x value. So this becomes 5 plus 2 times, what is y? Y is minus 5 over 8. And then I have to simplify that. So this becomes 5, and then this 2 and that 8 are gone, so it's minus 5 over 4. And of course I can usually use it the fractions, so it becomes 20 minus 5, so it is 15 over 4. So that is the other answer. These are exact values, and these numbers were so that these are exact values. So if I just calculate 15 over 4, you see that this 3.75 is also exact value. So, but you need to understand why the ideas. So no, don't worry about calculations or whatever. So I don't know why GeoGebra is telling this is usually used when this is approximation. But this is not approximation, I think this is the exact value. So let me divide by my calculator. So yeah, that is definitely, that's the exact value, because yes. Anyway, so I hope that this lesson is also simple for you. Any questions? I will write on a Schoolsoft which parts of this, but let me just tell you, if you want to do some practice, today's lesson is on page 70, 71, and 72. And the exercises are on page 72 and 73. Okay, so I will stop this recording.